Hello guys, in the previous video we have already discussed about one leet code problem, number of island. So in this video I will discuss about one new problem which is the extension of the previous number of islet problem, and that problem is number of closed island, which is leet code next problem. Let's understand what is the problem statement. Given a 2D grid consists of 0 and 1. 0 denotes land and 1 denotes water. In the previous problem, 0 was denoted 0 denoting 0 was denoting water and 1 was denoting land. But in this problem, the meaning of 0 and 1 is interchanges. That means in this problem, 0 means land and 1 means water. Okay, 0 means land, 1 means water. An island is a maximal 4 directionally connected group of 0. 0 means land. That means an island is a maximal 4 directionally connected group of land. And what is closed island? And closed island is a island totally surrounded by one, that means water. Closed island, that means island which is totally surrounded by water. Totally, that means which is surrounded by water from left, right, top and bottom. That means that island which is totally surrounded by water is called closed island. And 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 what is island? Island is maximal 4 directionally connected. 4 directionally, that means vertical and horizontal, up, down, left, right. You cannot connect diagonally. Okay. And if you are unable to understand what is island, then I will suggest that you must go and see in the just previous video of this lecture, in which I have discussed about the number of island. Okay, so let's understand this question. To understand this question clearly, I am taking the same example that I have taken in the number of island problem. Okay, for simplicity. Number of column was 5 and number of row was, okay, number of column was 5 and number of row was 4. 1 2 3 and 4. Okay, and one more column. Okay, and here 0 denotes land. Here 0 and 1, meaning of 0. 0 denotes what? 0 denotes 0 denotes land. 0 denotes land and 1 denotes water. Okay, water. So okay, so let's fill let's example like that. 0 and 1 1 1 1. Let's fill speedily. Okay, this will be filled with water, and let this is land. Okay, this is land. 0 denotes land and 1 means water. If this will be the example or this will be the grid, then let's this is the, that means you can connect island for horizontal or vertically. You can connect like horizontally all land. Okay, you can connect, that means this 4 land will come, that means combination of this 4 will make one island. We cannot connect this because this is diagonal 4 direction, that means we can connect either horizontally or vertically. We cannot connect diagonally. Okay, cannot connect diagonally, so we cannot connect this land. So this island will be different from this island. Okay, so the number of island is This is the first island, here is second, and this will be the third island. Okay, but the total number of island is 3, but it is not necessary that all island will be closed island. Only those island which is surrounded by water in all four direction, that means bottom up, that means surrounded by water in all direction, that only island will be closed island. So first we have to find what is island, and then we have to find closed island. First let's find total number of island, then we have to eliminate those island which is not closed, then remaining left will be closed island. Okay, let's one more time, I'm repeating. First we have to find total number of island. If you are able to find total number of island, then check for every island is it closed, and try to eliminate that island which is not closed, then remaining left will be the number of closed island. So let's check for every island. This is the one island, 2 and 3. So let's check. To check is it closed island or not, to check it is closed island or not, that means how could you able to check is it closed island or not. For that you try for each, that means in that island there are 4 land, 1 2 3 4. So try for each land. Okay, let's try for that land and check for all, that means check for all direction, right, left, top and bottom. Okay, for each land try in all 4 direction and check is it surrounded by water or not. If it is surrounded by water, that means right. If there will be at least one land in this island or any island, if there is at least land which is not surrounded by water, that means this island will be not closed. Okay, so let's check for this. From in this direction, sorry, that means this 0 is surrounded by land, so there is no violation. Land can be surrounded by land in Iceland. Okay, so there is no, let's check. This is the here is land, so don't worry, land can be. Now check in in below direction. In below direction there is land. Okay, but in above direction, this is go beyond or out of the grid, and this indicating that this land is not surrounded by water in this direction, because because it is not given that water present in outside the grid. So that means in this direction this island is not surrounded by water. That means there is, if there is at least land in any island violet or which not surrounded by water in any direction, then that island will not be the closed. So that means this island will not be closed. Now check for another, for this island. If you try in all 4 direction, in this direction water present, in this direction water present, in this direction water present, and in this direction water is present, that means this island is closed. Okay, that means this island is surrounded by water in all 4 directions, that means this island is closed. Now check for this. In this island check for every land, check for this land. This land is surrounded by water in above direction. Okay, that means right. In this direction surrounded by water, that means right. And in this direction it is surround, that means connected with land, so there is no problem, land may be. Okay, now in this direction this is go beyond or out of the grid. This indicates that if any land go beyond, if any land in Iceland go beyond, then this indicating that this island will not surrounded by water in this direction, and so this is not closed island, this will be not closed island. Okay, that means this is not closed island, this is not closed island. this is not closed island, and but this is closed island. So the number of island is 3, but number of closed island is in this grid is only 1. Okay, so the main question is how could we eliminate the which island which is not closed. If you, that means the main motive or main approach is what? Let's first total island, and if you able to eliminate those island which is not closed, then remaining will be closed. So how to eliminate? Let's assume that if 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 we are able to make this, because this is what say, this is not closed. So let's able, if you are able to make this zero value is 1, and also this is not closed, so make this zero value is also 1, and then assume that this is the original, this is the grid, and then the, if there will be, or then in this grid the count, or the count of island, or the number of island will give the correct answer, and that number of island will be your number of closed island. So that means I am saying that any island, that means any island which is at the border, if in any island at least one land which is present at the border, that island will not be the closed. So let, but this island there is no land which is at the border, okay, that means which is at the edge. So first try to find those island which is at the border, or which is at the end, or which is at the edge. So if you try to make, that means you first to eliminate those island which is in which at least one land which will be at the edge or at the corner. So for to eliminate those island, let's start make DFS call from all edge corner, okay, all edge box. If you try, if you are able to make this DFS call, that it's ensure that all non closed island will be eliminated. Okay, and in this process don't increase count value. Okay, that means if you try to make DFS call from first in this corner edges, that means in first, that means I0 or I m minus 1, j equals to 0, and j equals to n minus 1. If you try to make DFS call first by the all four corners or four edge boxes, then these component or these island will be eliminated, and during this DFS call don't increase count. So by this method you make this 0, all 0 will be 1, and if you are able to make all 0 will be 1, then after that we again make call for all grid, and that the count, and the count value of island will the give you the correct number of closed island. Okay, for that purpose let's start how to proceed solution. For that I am saying that how could we able to make or eliminate island which is not closed. For that we will make DFS call from all corners land which is present at the corners. Then by this method we are able to eliminate, because those island which is not closed, which is present at the corner. Okay, so make first DFS call for corner. By this method we are able to eliminate this island, so the now then remaining island will be closed. Okay, so for this purpose make visited area. This will be the visited, and make initial count equals to 0. This count indicates the number of closed island. Okay, initial count value equals to 0, and if when we make DFS call from corner, DFS call from which land which is present at the corner, then during this duration we we can't increase count value, because this count value will indicating that this is the number of closed island. But during this DFS call, this will be not the closed island, so will not increase. Okay, and after that, if you are able to eliminate those island which is not closed, then after again make DFS call for all grid, or then after that we will increase count value which indicating the exact closed island. Okay, for that purpose, let us start from here, make tick. That means start from here. If you start from here, then make visible, and then this call for this 0, and this also make visible. Then it is try for all is land. This can try only land number, not zeros, because one is 0. So this can try for this one denotes water, sorry. So this 0 or land only call, which is only call for 0. This 0 try for this 0, but this is already visible. Now this 0 tries never 0 and make this visible. That means this is visited. Now this 0 try for this 0 and this 0, but it cannot call for this because this is already visited. Now it is try for this 0. Okay, now make visible. And if you are able to understand the DFS approach, then this, that means now your DFS call will be ended, because this try for this 0 and this 0, but it is already visited. This is already visited, so cannot try, and it return its call to this 0, and this 0 already try for all its neighbor. Now call will be returned to the main function, and main function will try for 0, then this 0 try for this 0. But if it try for this 0, but this 0 already visited, so you cannot try, and after that main function call will be returned. That means first DFS, first island which is a start from this first DFS call is done. Now that means this is visited, this is visited. Now it's try from your DFS call is try for this box. Now that means this box is DFS call. Now try to start from this box. Okay, then DFS call will be try for this, but visited, already visited, so DFS call will not try from here. One DFS call is tried from here. Okay, that means one DFS call is started from here. Now try for this, but already visited. Now try for this to start DFS call, but one denotes land, sorry, one denotes water, so cannot make DFS call. This try for this one, this is already one, so cannot start from water. Now try for, because first we will try for all land which is present at the border. Now this is also one which is water, we cannot start. Now this is land. Okay, so this is land. Now maybe DFS call started from here. That means new island formation is started from here. Maybe let's check. Is it visible? Is it visited? No, it is not visited. So we can start DFS call from here. Metric denotes the DFS call, but we cannot increase count here because this is not closed. We are trying to eliminate those island which is not closed. Okay, so now this make this visited. Now this 0 try for from all 4 direction. This is out of grid, so cannot try. Here is, then it will try from, this is out of the grid, so cannot try. This is try from for that, but this is 1, so that means water cannot try. This is go out of block, out of grid, so cannot make DFS call. Now this is try for this land and try this land, and it is unvisited, so let's visit. Okay, let's visit this. Okay, and this 0 try for all its neighbor. This is out of the grid, this is water, so cannot, this is water. Here is land, but which is already visited. Okay, so cannot, and so the for this land DFS call will be ended. Okay, now we have try from here. Now DFS call try to start from here, but it already visited, so we cannot start. Now try to start from here, but this is here it is water. Okay, here is water present, so we cannot start. We have make already DFS call till now. Now try to make DFS call from here, but all water, so cannot start it. This is also water. This is also water. Okay, so we cannot now. We have a start from here until now. Now this is last box in edge that in which is at the edge. So now let's try for that. But this is here is land, but it is already visited, so cannot start from here. That means we have tried to make DFS call which is present, DFS call from land which is present at the edge of the grid, and by this method we are able to eliminate those island which is not closed, like these two island. And how are you able to eliminate? Because if you are able to make the box value of or the land value of this island is, if you are able to make visible, that means you cannot restart DFS call from here. And if you are not a start DFS call from here, that means what? This zero is virtually make one already, make one. Okay, already replaced by one, as you imagine. If met visited, if you feel visited of that value is one, that means you can imagine this is this the DFS call cannot start from here, or that means any island with not formation start from here. That means imaginary, we can imagine that this all these are replaced by one. Okay, the value will not be replaced, but visited make visited value zero, ensure that we cannot start or we cannot include DFS. Now if now now again a start DFS call, this is the phrase. Okay, and the the number of island in this grid will be your answer, and these are called number of closed island. Now let's again start DFS call from here. Okay, this is already visited, so cannot start DFS call. Already here is land. Now try land, but already visited, so we cannot start DFS. This is water. Okay, so cannot start. Here is water, so okay, let's change color. Here is land, but already visited, but this is water, so we cannot. Now start from here. This is land, but already visited. Already visited. This is water, so cannot start. Let's try from all water, so cannot start. Now if you are here, you can start. It, it is land, and is it unvisited? Yes, it is unvisited, so you cannot start DFS call. And if you are able to start forming new island or make DFS call, that means you are able to find one, you are able to initiate one number of closed island, at that time we will increase one count value. Okay, and this will be the your answer. Okay, and this, and then if you start DFS call from this land, then it just denoted a new closed island formation is started. Okay, has started. So for that, make also make visited, and now this land try for this neighbor, but let's try for all neighbor. Okay, let's try for that, but it's not land. Now it's try for above, this is also not land. Now let's try for left, is also not land. That is, this is water, so cannot call. Now this is also land, so now this DFS call will be ended, and this now we have done for that. Now let's start from here, but once it not water, so we cannot start DFS call. Now start from, now start try to start from here, but this is not, this is also water, so we cannot start. Now this is water. Okay, now if you are reach edge here, then this thing, indicating that this is land. It is chance, or maybe DFS call will start from here. For that, check visited array, but this box is or this land is already visited, so we cannot start DFS call. Now let's, this is land and it is visited. No, it is, yes, that means if this is land, now let's check, is it unvisited? No, this is visited, so cannot start DFS call from here. And now we have travel all the, we have tried, or we have tried to start DFS call from every box of this grid or every land of this grid. So now your count value will indicating that this is the correct answer. So now let's code this approach. That means first make DFS call at the corner side of this grid, and this will eliminate, and during this DFS call don't increase count value, and again make, then now again make DFS call for each, for all box of the grid, and at this time if there will be initialization of Iceland, or if there will be initialization of DFS call, then at that time count will be increases. Okay, let's come, let's code. Now let's code. That means this is simple, this is similar to the number of Iceland, but difference is that we have to make two for loop. That means first make visited array. Okay, and try first make visited array. Let's first what is the grid, make this name array for simplicity, and let's row m denotes number of rows, m equals to array dot length, and then n denotes number of column equals to array 0 dot length. Now what's again, the next will be make DFS call, or try to start DFS call from all the corners, land present at all the corners. With that, by this approach we are able to eliminate all the island which is not closed. Okay, let me I equals to 0, I is less than m plus 4 int j equals to j is less than and j plus plus, and you can call only if you can only call DFS call if this will be land and must be unvisited. Okay, then only you can call. If array of I comma j must be 0 denotes land, and also must be visited of I comma j equals to 0, then only you can call DFS. Just we will decide later what will be the parameter. Okay, and during this don't increase count value. Okay, because we have to eliminate first potentially count equals to, now same approach, but okay, one more time we will call only for corner. Okay, we will call only for the corner box, for so that means either I equals to 0 or j equals to 0, or either I equals to m minus 1 or j equals to n minus 1. For that for that for, for that value we will only call. That means we have to call only if I equals to 0. Okay, or j equals to 0 or I equals to m minus 1 or j equals to n minus 1, then only you can call for eliminating. Okay, and then and under this, if this is land and unvisited, then only you can get DFS. Now let's try for all, and now we'll try for all. Again make DFS call from every end. In this call, if DFS call will, in this for loop, if DFS call will be done, then during it you must have to increase count value, and this will be the answer. And in this condition, this is not necessary. That means I must be 0 or anything. We call for every ij. Okay, and we'll call only if if area equals to land and and that will be unvisited. And let's pass array I comma j and visited. Okay, similarly array ij visited, and one make DFS call. When make DFS function, let's make DFS int array int row int column, then int visited array visited to the array. First we have to make visited of I row column equals to 1. Then try for every node, try for all 4 direction, and for that we will make row and column for traveling in 4 direction. -1 if you go upward, and 0 and 1. For this row and column I have already discussed in previous videos, so I recommended you to go to the previous lecture and try to understand why I am writing this row and column. Okay, if you go, then column will be same and row will be, if you go, then column will be same. Okay, in right direction column will be increase, in below column will be same, in left column will be minus. Okay, then we have to try for, if you are in any node, then try for all its number 4 up down. I equals to 0, I is less than 4, and I is plus. And you can call only if that neighbor, you can call only if you are at, if you are at this value, then you can call only if the neighbor must be land and unvisited. Neighbor must be land and unvisited. If in this area of, and if you are at ij or row and column, then if moving in any direction, up down left right, then new int row equals to row plus row 5, and new, then int new row equals to row plus row 5, and new int column equals to column plus column of I. And now if new row and new column, if that value will be 1, and also if visited of that new row new column must be 0, then only you can make DFS call. Okay, and under DFS we have to find array new row new column visited. Okay, I think this will be, this is the code, and we have to return count. So I think this code should run. Okay, let's check. If there will be any compilation error, we'll try to eliminate. Okay, variable v is cannot find symbol. Oh sorry, we have no visited array. First declare visited array new int size m cross n. Now let's try. Now again compilation error. Now let's try to run array index out of. Okay, sorry. If you are trying to make child call, then first ensure that the call will not go out of the grid. Okay. New row is must be greater than equals to 0, and new row is less than must be less than m, and new column should be greater than equals to 0, and new column must be less than n. Okay. There are many compilation errors. Let's try. Only one test case passed. Why? Here answer is wrong because why? Array. Okay, sorry here. Due to previous problem here, I think 1 is the land, not 0 will be land. So make that child which will be land. I think this could. Okay. Test case is passed. Let test check for all test case. Now this is a better, that means this is a good question. Okay, this is a good question. I think if you are able to solve this question, I think there is something good knowledge, okay, for that type of question. Okay, thank you. And time space complexity will be discussed in the next video. Okay, thank you.